My name is Nur Erna Safia binti Abdul Syukur.
My name is Nurul Sofia binti Mat Fuzi.
And my name is Safia Akila binti Samsuadaha.
Case study 1, compound interest. Introduction of compound interest. The process by which an asset earning whether from interest or capital gains are invested to produce further earning over time is known as compounding because the investment will yield returns from both its initial principal and accrued earning from earlier periods. This growth calculated using the exponential function occurred. Problem statement of case study 1. Tina had been working as a doctor at Subang Medical Center for 9 months and she plans to save her money in RHB ordinary fixed deposit for her future use. She wants to deposit RM10,000 for 2 years. The interest rate charged by RHB is 2.10% compounded semi-annually. Objective case study 1. First, to determine the accumulated amount at the end of her saving period. Second, to calculate the total interest received by Tina. Third, to calculate the amount balance at the end of the saving period if Tina add another RM10,000 into the same account 2 years after her initial deposit. Fourth, to calculate the accumulated amount at the end of the saving period if the interest rate changed to 2.50% compounded quarterly 6 months after her initial deposit. Case study 1, result and discussion. This is the timeline from P until else. P equals to RM 100,000, K equal to 2.1% which is 0.021, M equal to 2 semi-annually, T equal to 2 years, I equal to K over M equal to 21 over 2000, N equals to M multiplied with T equal to 4. Objective 1, to determine the accumulated amount at the end of her saving period. To find S, we need to use formula S equal to P brackets 1 plus I to the power of N. S equal to 100,000 bracket 1 plus 0.021 over 2 to the power of 4. S equal to RM 104,266.61. Objective 2, to calculate the total interest received by Tina. To find the interest, we need to use formula I equal to S minus P. I equals to 104,266.61 minus 100,000. I equals to RM 4,266.61.
Objective 3. To calculate the account balance at the end of the saving period if Tina add another 10,000 ringgit into the same account 2 years after her initial deposit. T1 equals 1 years, T2 equals 1 years. P1 equals 100,000 ringgit. Additional deposit P2 equals 10,000 ringgit. M equals 2, K equals 0.021, I equals K divided by M equals 0.021 divided by 2 equals 21 over 2000. N1 equals 2 times 1 equals 2. N2 equals 2 times 1 equals 2. First, accumulated the initial deposit. S1 equals 100,000 multiplied by open bracket 1 plus 21 over 2000 close bracket raised to the power of 2. S1 equals 102,111 ringgit and 3 cents. Next, add the new deposit after 1 years. P new equals S1 plus P2. P new equals 102,111 ringgit and 3 cents plus 10,000 ringgit. P new equals 112,111 ringgit and 3 cents. Next, accumulated the new principal for another 1 years. S equals 112,111 ringgit and 3 cents multiplied by open bracket 1 plus 21 over 2000 close bracket raised to the power of 2. S equals 114,477 ringgit and 72 cents. Objective 4, to calculate the accumulated amount at the end of the saving period if the interest rate changed to 2.5% compounded quarterly 6 months after initial deposit. The initial deposit is 100,000 ringgit. We divide the saving period into 2 parts. For the first part, T1 equals 6 months. We convert that into years. 6 divided by 12 equals 0.5 years. K1 is 2.1% equals 0.021. M1 equals 2. So I1 equals K1 divided by M1, 0.021 divided by 2 equals 21 over 2000. N1 is M1 multiplied by T1, 2 times 0.5 equals 1 period. Now for the second part, T2 equals 1 years and 6 months. We convert that into years. 1 plus 6 over 12 equals 1.5 years. K2 is 2.5% equals 0.021. M2 equals 4. So I2 equals K2 divided by M2, 0.025 divided by 4 equals 1 over 160. N2 equals M2, T2 equals 2 times 1.5 equals 3. Now we apply the compound interest formula into step. Step 1, calculate the amount after the first period. We use the formula S1 equals P times open bracket 1 plus I1 close bracket to the power of N1. Substitute values. S1 equals 100,000 ringgit multiplied by open bracket 1 plus 21 over 2,000 close bracket to the power of 1. S1 equals 1,050 ringgit. Step 2, apply the new interest rate to this amount. We use the formula S equals S1 multiplied by open bracket 1 plus I2 close bracket to the power of N2. Substitute the values. S equals 100, 1050 ringgit multiplied by open bracket 1 plus 1 over 116 close bracket to the power of 3. After calculation, the final accumulated amount is 102,956 ringgit and 55 cents.
Case study 2. Annuity. Introduction of annuity. Annuities, which are similar to regular payment obligations such as apartment rent, mortgage installment, or auto loan repayments, are made up of a series of consistent payments disbursed at regular interval. Case study 2. Problem statement. Muhammad bought a house that cost RM529,200. He paid a down payment of 30% and took a loan from BSN Residential Property at 4.5% compounded monthly to finance the balance. The loan is to be repaid over 30 years by monthly installment. Objective 1. To determine the amount of monthly payment paid by Muhammad. 2. To calculate the total interest incurred by Muhammad. 3. To calculate the total outstanding balance if Muhammad wants to settle the loan immediately after the 300 payment. 4. To determine the outstanding arrears that must be settled on the next payment if Muhammad missed 5 consecutive monthly payments. Case study 2. Result and discussion. Cost price CP is RM529,200. Down payment DP 30% times CP, which is RM529,200, equals to RM158,760, and the balance CP minus DP, which is RM370,440. We have M frequency, which is 12. We have K rate, which is 4.5%, equivalent to 0.045. We have T time, which is 30 year. We have N equals to MP equals to 12 times 30, which is 360. We have I, K over M, which is 0.045, divided with 12 equivalents to 3 over 800. The first objective, to determine the amount of monthly payment paid by Muhammad. So the formula that we use is A equals to R in a bracket 1 minus open bracket 1 plus I close bracket to the power of negative N close bracket over I. Then we're gonna switch the place of the formula and we will have R equals to AI over open bracket 1 minus open bracket 1 plus I close bracket to the power of negative N and close bracket. So when we insert our number into the formula, we will have R equals to open bracket 370,440 close bracket, which is our A. Then we have our I open bracket 3 over 800 and close our bracket over open bracket 1 minus open bracket 1 plus 3 over 800 and then close our bracket to the power of negative 360 and close our bracket. The answer for our R is RM1876.97. Objective 2, to calculate the total interest incurred by Muhammad. So the formula that we will use is I equals to R in a bracket N minus A. So when we insert our number into our formula, we will have I equals to 1,876 ringgit 97 cents, which is our R, and open another bracket 360, which is our N, minus with our A, which is 370,440. Our I equals to RM305 269.20 cents.
Objective 3. We determine the number of payments that are still unpaid. The total number of payment is 360 and Muhammad has already paid 300, so the number of unpaid payments is 60 months. We use the annuity formula AN equals R multiplied by 1 minus in bracket 1 plus I raised to the power of negative N divided by I. We substitute the values. R is 1,876 ringgit and 97 cents. The interest rate per month I is 3 over 800. The number of months N is 60. We calculate 1 plus 3 over 800, raise that to the power of negative 16, then complete the rest of the calculation. The total outstanding balance that Muhammad needs to pay is 100,679 ringgit and 51 cents. Objective 4, to determine the outstanding arrears that must be settled on the next payment if Muhammad missed 5 consecutive monthly payments. Since he missed 5 payments and the next one is also due, we add 1, so the number of unpaid payments is 6. We use the future value of an ordinary annuity formula. Sn equals R multiplied by in bracket 1 plus I raised to the power of N minus 1 divided by I. We substitute the values. R is 1,876 ringgit and 97 cents. The interest rate I is 3 over 800 and the number of period ends is 6. Calculate 1 plus 3 over 800, raise it to the power of 6, then minus 1, divide by I, multiply by R. Then result is 11,367 ringgit and 93 cents. In conclusion, compound interest and annuity are important financial concepts that help individual business to make financial decisions. Compound interest show how money can grow over time if interest is charged not only on the principal but also on the interest itself. On the other hand, annuity acquaints us with regular and fixed payments over a period of time, such as in loan repayments. By understanding how annuity works, especially under the impact on interest, we can prepare for the better management of financial commitments, such as mortgages, and create secure income plans for the future. These two laws give us the insight to invest time and money wisely, whether saving, investing, or borrowing. They remind us that financial responsibility today can lead to the greater stability and return tomorrow.
Thank you.